Hi guys, in this video we will compare the power from one solar system that's configured all south in Thailand and one solar system that's east and west. And then the third one that is only west. Those are the three systems we will compare. But the key factor that we're going to be looking at is the tilt of the panels, the slope on the roof. We're going to compare the perfect configuration, which is 15 tilt, 15 degrees, and everything south. That's the perfect configuration for all the panels. And then we're going to look at east and west with a very high tilt, 40 degrees. So I'm doing that because it's actually quite a common situation where a customer has a house where the roof has a very steep slope, and we have to compare that, the production, if we put the panels on the roof of the existing house, compare that to if we make a frame that's perfect, meaning this. So we have to compare the power and see how we can make a cost analysis and see what is the best thing to do for a specific customer. When we compare making a frame to using the roof of the existing house. Obviously, there are other factors involved here too, but we're going to look at only the energy difference and see if we can make any conclusions. So we're going to start at looking at 6.5 kilowatt of panels. It's about 14 panels around there somewhere. Doesn't really matter because the numbers don't change depending on this. It will all be in relationship to each other anyway, so you can put anything you want there. And then the tilt is perfect, and this is south 180 degrees. So we're going to look at the production. 9,000 kilowatt hours per year. Then we can go back. So this is a cool thing about this simulation program. It's very easy to use, and you can go back, change a few things, and then compare. So we're gonna go all west to start. All west is 270. Tilt slope is 40. So imagine that's a pretty steep roof on a house, but it's definitely within normal. It can happen sometimes, and for this customer it is the case. This is the exact situation. So then what happens if all the panels are put west at the 40-degree angle? Let's see, 7584 total kilowatt hours per year. Okay, so let's now look at the numbers. We have the first that we already ran the simulation, 6.5 kilowatt, all south, 15 degrees. That's the perfect. So this is the frame. This is what will happen if we make a frame that's perfect. Okay, this is the last simulation we ran. This is if we put all the panels on the west side of the house on the steep slope. Then we get 7,584. It's a 15.7% difference. So we get 15.7% less. Okay. But then many people will say that, well, if you have a house like that, you're likely to have something on the east too, that you have the possibility for east-west configuration. And I definitely agree with that. Many houses, and actually the house in question here, has an east-west configuration, so we can put 50% of the panels on the east and 50% on the west. So then what changes? I have that down here. We don't have to run the simulation, I've already done it. So we have 6.5 kilowatt, 40 degrees, and then half west and half east. Interesting here is that actually east gives a little bit more. That may be surprising to some people. Total 7708 kilowatt, should say kilowatt hours here, per year. So it's actually a little bit more than the All West, not too much, but and then the percentage difference compared to All South is 14.4. Now the most interesting thing for me here is that the difference between East and West compared to All South is only 1.3%. That's not much. But there's one factor that's easy to forget, and that is that for this, the curve that you're going to have in morning and afternoon is going to be skewed towards the afternoon, while this one is going to be more flat. So that is an important factor here that you have to consider. But let's not get too much into that here because it gets too complicated, because what we wanted to compare when we started the video was to compare what happens if we put the panels on an existing steep roof that's either all west or east and west, and compare that to if we make a new frame that's perfect. So we see here that let's, for simplification, we'll say that the difference is 15%. So is that a lot? Well, yeah, it certainly is a lot. But what you can do, you can compensate for that by adding a few panels. So what we have to do really is compare what is the cost of adding a few panels compared to the cost of making the frame. So now we can guesstimate that if we make a frame for 14 panels, that's this example, we would have a cost of between 20 and 25,000 baht. Just simplification. It could be plus minus depending on different factors, but anyway. And then if we add 2 panels to this one, we will have an additional cost of about 12,000. So that means that overall, we would have to say that the best solution is to use the existing roof and add a few panels. That's the best solution compared to making a new frame and putting them there. So, but the key is that you have to add a few panels. So if you're already maximizing out the inverter, then you could have a problem. You can't add those extra panels. So if that's the case, then maybe it's better to go with this one. So that's some food for thought, guys, and that shows you that if you have a very steep roof, yes, there's significant differences, but you can compensate for it. But then the question is, do you have the power that you need, or don't you? So there's a few factors there that you can think about, but the difference is if you think about the decision to make a frame or to add panels, whichever you do, the difference between those two decisions is only maybe 10,000 baht or a little bit more, depending on the frame and things like that. But that means that actually, whatever you decide, it's not gonna have a major impact on whatever you do. But the key is that you have to be able to add a few panels. If you are not in this situation, then you should go for the frame. So that's the key there. Okay, guys, take it easy.